In this video, I am going to give some details on gauntlet number 3, kinematics. So let me create an experiment here, and this is going to be used with the motion sensor. The little twist on gauntlet 3 is we have to determine intervals of time through which a cart accelerates. So I'm going to take a cart and accelerate down an incline, and I'll click start here. And I get some data. Now for this gauntlet, you're going to need a lot more data. You're going to have finer increments of for the data collection. So if you go to setup, the setup button here in the upper left hand corner, I can change the sampling rate. Right now it's grabbing 10 samples per second, which is quick, but we can go better than that. We can go, let's try 50 hertz, 50 samples a second. Close that up and let's try it again with another cart. And I'll say start. And you can tell I get a lot more samples in that time frame. You can tell the green versus the red. So let me get rid of the red trial here for a minute. This will completely get rid of the data over here on the left and scale that. So the sampling rate is one thing you can change with this lab to get finer increments. You can even go higher than 50. If you go too high though, it gathers too much data and it'll see every little bump, which may be not a good thing. I'm going to go ahead and show the velocity and acceleration graphs as well. Alright, and again grab this and grab it and bring it down below the position graph, and then acceleration below the velocity graph, and then make it a little bit bigger here so you can see everything. Okay, so you have your graphs there. So one of the things you're going to have to do is determine intervals of time or changes of time for a given distance. So for sake of argument, let's say I'll use the smart tool. Let me click on this graph here. Click on the smart tool, and let's bring this down to that data point. Get it even, see if I can get it even. 0.8. That's 0.8 seconds there. 0.8 seconds, and you'll notice if I click on any one of these corners of this cursor, I can click and drag the corner, and if I drag that out, this is the delta tool, it'll take me to a different part of the graph, and it'll tell me the change in this case, this is position. It's 0.45 meters over 0.2 seconds. And if I click and drag it again, I can get different increments of time for the deltas. So the delta tool is going to be very useful because you have to determine how much time elapses for a given change in position. And you can do this with the velocity graph and acceleration graph, and it's done simply by dragging out one of the 4 corners of the smart tool.